Hi, welcome to this third lecture session of the course Database Management Systems. This session is dedicated for discussion on conceptual database design using ER modeling. The contents covered are steps in database design process, ER concepts like entities, attributes, associations, etc. And we will also learn what are the various notations used in ER modeling. Then we discuss class hierarchies, how superclass subclassing concepts can be captured in ER modeling. Then we also have brief introduction to conceptual modeling using UML. Let us first look at the major steps in database design process. First, we do requirements analysis, which is a normal very initial step in any software development process. The purpose of this activity is to understand the domain, identifying the data that need to be stored in the database, and identifying the constraints that need to be enforced on the data. The second step is, once we are clear with the requirements of the database or the application that uses the database or the domain, then we will think about conceptual database design. And normally we can use ER modeling or UML for designing these conceptual schemas for the database. And this conceptual database design or conceptual schema gives some preliminary idea about the data we are going to store in the database. And otherwise we can call it as semantic model. It is part of semantic modeling. Otherwise we can call it as semantic conceptual schema or simply conceptual schema. It is called as conceptual database design step. Once we are done with the ER modeling, that is conceptual database design is done, then we need to carefully translate the conceptual schema, semantic conceptual schema into logical schema. While designing the logical schema, we will be using the constructs that are specific to the data model that is supported by the specific DBMS. The conceptual database design step is common to all database management systems or all data models. And once we are done with that, we need to decide upon what is the data model or the database management system implementation we are going to use to realize our database. It could be relational data model, it could be object data model, it could be network model, so on and so forth. Every database management system supports a specific logical constructs or logical schema data model. In relational data modeling, the basic constructs used are the tables and relations. Similarly, in object databases, the basic constructs used are objects. So once we are done with the conceptual database design, we need to carefully translate the schema, conceptual schema, to the logical schema by using the specific data models which are supported by the database management system implementation, like RDBMS or ODBMS, so on and so forth. Then once we are done with the logical database design, then we need to think about the refinement of the schemas. Whatever logical schema we have arrived so far, that may contain some anomalies or undesirable properties in terms of redundancy. When there is more amount of redundancy in the schemas or the relational database design, then it may lead to inconsistency. Now we need to carefully eliminate that redundancy as far as possible. To do this, we apply the process or the activity called as normalization. This is called as refining the schemas or logical schemas. When we apply this normalization process, we bring the schema or logical schema to the required level of satisfaction so that it will eliminate, it is not having much of redundancies and which will not lead to inconsistency. Then we need to think about physical database design, where we will decide upon the indexing that need to be used, and then clustering that need to be used, and storage formats, so on and so forth. So these are the major steps in database design process: requirement analysis, conceptual database design, logical database design, refinement of the schemas, and then physical database design. Now we will have detailed discussion about ER modeling, and ER modeling is a popular high level, or otherwise we call it as conceptual data model. It is an approach to design semantic conceptual schema of the database. ER model allows us to describe the data involved in a real world environment in terms of objects and their relationships. and which are widely used in design of the database. And what is the purpose of the ER model? ER model provides preliminary concepts or idea about the data representation which is later modified to achieve final database design. So, this gives some initial idea, preliminary idea about the data that is being stored in the database. And then now let us start looking into the important concepts or the notions that are used in ER modeling. The foremost concept or most important concept used is the entity. Entity is an object in real world or some idea or some concept which can be distinguished from other objects. This is called as an entity. Like for example, a person, school, class, department. It could be a tangible object or it could be some concept also, like weather, salary, temperature, so on and so forth. The one important thing that need to be noted is entity has independent existence. Each entity has independent existence. Then each entity belongs to a type, entity, we call it as entity type, that defines the structure. And the analogy is, if we look at object oriented programming languages or object orientation, we have class and instances. Class defines the structure of objects, whereas when we instantiate the class, then we get instances or actual objects. Similarly, entity type is going to define the structure for entities of that type. Every entity belongs to some entity type, and similar kind of entities, the collection of similar kind of entities is called as entity set. For example, if we look at that, this employee schema or employee entity type, here employee is an entity type where it has three attributes: employee ID, name and age. Now these 1, 2, 3, E1, E2, E3, they are specific instances of type employee, and the structure of these instances or the entities is defined by this entity type, defined at this entity type. So whenever I am instantiating an entity of this type, it must contain employee ID, name and age as attributes or properties. So that is why first entity is 101, name is Ram and then age is 22, second and third. And this is entity type which is going to define the structure for the entities, and then these are the actual instances or we call them as entities, and collection of similar kind of entities is called as entity set. Then attributes. Attribute reflects a property of an object or entity. We have following types of attributes. We have simple attribute, we have composite attribute, single valued attribute, multi-valued attribute, derived attribute and then stored attribute. Simple attribute means it is very simple attribute which is not complex or composite. What do we mean by a composite attribute? Some attributes, they contain subcomponents. For example, if you take address attribute of a person or student, it may contain subcomponents as the street number, door number, city, zip code, state. So that kind of attributes are called as complex or composite attributes, and the other attributes like name, it may contain only one value, or age, it may contain only one simple value. They are called as simple attributes. Similarly, we have single and then multi-valued attributes. A single attribute is one where you can store only one single value which has some meaning. And if it is a multi-valued attribute, what happens is not a single value, rather we will be storing multiple values. Suppose for a person entity, if I have phone number, if I conceive that, if I capture that as a single valued attribute, then I can store only one phone number. If it is a multi-valued attribute, what I can do is I can store his office phone number, a house phone number, mobile number, so on and so forth. That means it may contain multiple values which have some independently which have some meaning. So that is called as multi-valued attribute. Then we have derived attribute and then stored attribute. And stored attributes are those whose values are permanently stored in the database, and derived attributes are those whose value can be derived as and when required from some other value of some other attribute or stored attribute. For example, if we consider the date of birth and age attributes of a person entity, then date of birth is fixed, that is every person will have a specific date of birth. But age, if the company or the enterprise organization wants the age of a person or a student correct to the number of days or months, then every time whenever it is required, the correct actual or exact age in terms of months or days, whatever it is, can be always calculated based on the current date as well as the stored value of the date of birth attribute. So that's why the age now it can be treated as derived attribute, and the date of birth can be treated as the stored attribute. This is about attributes. We have simple and then complex attributes, single, multi-valued, derived and then stored attributes. Then let us have a look at the concepts related to keys. Candidate key, or simply we call it as key in this context, is an attribute of an entity type whose value can uniquely identify an entity in a set. So the value of a candidate key or simply key for an entity type which specifies or which provides unique identification to the entity in a set. Similarly, if we look at primary key, and there can be any number of keys or candidate keys for a given entity type, and one among them will become primary key of the entity type, and then remaining all other candidate keys will become the alternate keys. We call them as alternate keys. There can be any number of candidate keys. For example, if we consider the employee entity type, we have, let us assume that we have employee ID, which is provided by the organization or the company where he is working, which provides unique identification to the employee, and at the same time there is one more attribute called as social security number or simply SSN, which is also unique, which is provided by the government of that particular nation, whatever it is. So that's why both are unique. In that case, both provide unique identification to the entities in that employee entity set. So then both of them are called as candidate keys, and we can make one among them as primary key, and the remaining candidate keys will become alternate keys. Then coming to the relationship, it is nothing but association between two entity types or two entities. Now onwards we will be using the term entity and entity type interchangeably. Okay, so the association between entities is known as relationship. Then what is domain of an attribute? The set of possible values is known as domain of an attribute. If you take the attribute age, what is the domain? Normally let us consider that age of a person can be from 1 to 100 years. So 1, 2, 3, 4 up to 100, these are the possible values for any person under the attribute or the property age. So that's why this possible set or this set is called as the domain of the attribute age. And at the same time, every attribute will also be associated with the type, data type. It could be string, or it could be a number, it could be a real number, so on and so forth. Then let us have, it is one important thing to be noted is ER modeling is a technique for designing conceptual database, and it is graphical. It is basically graphical. So whatever concepts, notions we have to represent these notions or concepts, we have diagrams, we have notations, we call them as notations. Now let us have a look at the notions and notations used in ER modeling. The first one is entity type, the important thing. It is indicated by a rectangle, and next we have weak entity type. That is, some entities, normally all entity types will have one key, at least one key. That means which provide unique identification to the entities available in that set. But sometimes what happens is, in some cases, some entity types may not, they will have properties or attributes, but none of the attributes may be able to provide unique identification to the entities in that set. Such kind of entity types are called as weak entities. Now to understand this concept of weak entities, let us have a look at this example. We assume that we have employee entity type and we have dependent entity type. In a company we have employees, and then we also assume that each employee can have some dependents. In that case, the company rule says that an employee can have any number of dependents. Some employees may not be having any dependent, and the names of the dependents of a given employee cannot be same, but different employees can have dependents with same name. That is possible. Now I have captured this employee as entity type EMP, which has employee ID, which is a key, age and then name. Then I have dependent entity type which has name, age, and then relationship with the owner, that is employee. Some dependent may be son of some employee, some dependent may be sister of some employee, so on and so forth. So these are the specific attributes of dependent. Now if we carefully observe, look at the actual data that is stored. Let us assume that we have this kind of data available in the database. Now I have 5 dependents. The first dependent's name is Tony, whose age is 4 and who is daughter of some employee. And next Anita, 49, Tony, again Tony, 36, next Bill, 69 years, and then Tony, 4 years. Now if you carefully observe, as far as the employee entity type is concerned, we have 101 Ram, 104 Kiran, 110 John. And then what value of what attribute can provide as unique identification? If you look at employee ID, the value of employee ID for in that set can provide unique identification for the entities in the given employee entity set. But if you observe this dependent, no single attribute value can provide unique identification. Can I make name as the key, candidate key there or key there? Not possible, because multiple dependents may have more than one dependent in the set may have same name, like Tony here who has 4 years, and then one more dependent of Kiran, he is having same name Tony. So name cannot be a primary key. Then how about making age as the primary key? That is not meaningful, because multiple persons can have same age. For example, if you take this first Tony with 4 years who is daughter of Ram, and then Tony with 4 years, same 4 years, who is daughter of John, that is possible. So age attribute cannot become key for the entity type dependent. And then can I make the relationship as the primary key? It is not possible, because the same relationship may be existing for different dependents with their owners. So similarly, the Tony is daughter of Ram, and similarly Tony is daughter of John. So that's why that cannot become, that will not provide you unique identification for the entities in the entity type. So in that case, that kind of entity type is called as a weak entity. Then what is the solution for that? How we can provide unique identification for the entities in the entity type? It is possible only when it is associated with, or when it is having a relationship with the owner entity, some other strong entity. The entities who have a key, which have a key, are called as strong entities, and then those entity types which are not having any key are called as weak entities. The distinction, the diagrammatic notation distinction between these weak entities and then strong entities is, the weak entities, they are always have a double line border rectangle, whereas a strong entity, it will have only single line bordered rectangle. So that is the distinction. So how we can impart unique identification for the entities in the weak entity type? When it is involved in some relationship or association with the strong entity, then only it will get its unique identification. So that's why a dependent is always the dependent, the weak entity, weak entities will not have any individual existence. So they will always depend on some entity in the strong entity type or strong entity set. So that's why if you look at this particular Tony, 4 years, and then daughter, this particular entity, weak entity, is associated with one instance of strong entity type, and then whose name is Ram, and then whose employee ID is 101. So similarly, you take any weak entity, it is definitely has an association with some strong entity of some strong entity type. In this case, it is employee. So employee is the owner entity. Now dependent is the weak entity, and then employee entity type is the owner entity, and the relationship which is going to provide the unique identification for the weak entities is called as identifying relationship, and then we represent it as a double lined diamond. Of course, we have not discussed about relationships so far, so that's why let us defer that discussion. Now that's why weak entities, they don't have unique identification. They will get unique identification only in conjunction with some strong entity, a relationship with some strong entity type. And here the rule says that now what can become primary key for the dependent? The employee ID along with the name of the dependent can provide you unique identification for the weak entities in the weak entity type or weak entity set. For example, 101 and name Tony, because the 101 is a specific employee and he cannot have multiple dependents with same name. So that's why that provides unique identification to the weak entities in the set. Similarly, one more Tony is there in the dependent list, but he is associated with 110, that is John. So that's why two entities in weak entity cannot have association with the same strong entity. So with that is going to solve our problem. So that's why here the employee ID, that is the primary key of the owner entity type, and some other attribute of the weak entity can provide unique identification to the entities in the weak entity type. So that's why employee ID of the owner entity and then name of the weak entity type together can provide unique identification to the entities in the weak entity type. So this attribute which is going to participate in becoming primary key for the weak entity type is called as partial key. It is called as partial key. Here in this specific example for dependent, name is the attribute which we can consider it as partial key. Next is relationship type, which is represented, or simply we call it as relationship, which is represented using a diamond. And identifying relationship type, that is what we have seen just now when we are discussing about the weak entity and then strong entity. Okay, so when a weak entity is getting associated or having a relationship with its owner entity, that relationship is known as a identifying relationship. Okay, so it is, what is the distinction between this and this? This is a single line border diamond and it is a double line border diamond. Then all attributes, every entity type will have some attributes, and then we represent them in ovals and then solid line ovals, and then this can be attached to the corresponding entity type using straight lines like this. Okay, suppose if I have employee entity, okay, and then this is the attribute age, this is a oval that indicates the attribute, and this is the line which is going to join, associate, attach this attribute to the corresponding entity type. Then we have key attributes. If the attributes among the attributes of an entity type, you can have one or more attributes which provide unique identification to the entities in the set, that is called as a key. So we can also indicate or represent keys in this ER modeling. Whenever I have, suppose I have employee entity type, when I have employee ID as the attribute and then age as the attribute, then when I underline this name or title of the attribute, then it indicates that this attribute is going to provide unique identification, and this is a key attribute. Similarly, a given employee or given entity type can have any number of keys. For example, if it is having one more attribute called as SSN social security number, it also becomes a key. So in that case, I can underline this also. It indicates that this particular employee type has two keys. Employee ID is one key and then SSN is another key. And some attributes may be multi-valued attributes. For employee, let us assume that I have a attribute called as phones or phone numbers, which is a multi-valued attribute. That means he has a home phone number and mobile phone number, office phone number, so on and so forth. So it is, rather than having a single value for that attribute, you will have multiple independent or individual values independently which has some meaning. So that kind of attributes are called as multi-valued attributes, and such kind of attributes are indicated by double line ovals. If it is a single line oval, it is a simple attribute or single value attribute, and then if it is a double line, it is multi-valued attributes. And in some cases there can be attributes which are composite or complex. For example, if you consider address attribute, if you assume the address attribute of a person or employee which has subcomponents like door number, street, zip, city, so on and so forth. So how can we represent that? This is a notation used for that. Let us consider this. I have address. So this indicates that it is a composite or complex attributes, and which can have the subcomponents like door number, street, zip, city, so on and so forth. So it is a normal, simple and then single valued attribute. It is a multi-valued attribute, and then this is a complex attribute or composite attribute. They have subcomponents. In some cases, what happens is not a single attribute or a collection of attributes can become may provide unique identification. In such case, what we can do is, suppose let us assume that there is an entity type called E and which has two attributes A and B, which together are going to provide unique identification. Okay, so then I cannot simply represent it underlining this. So this indicates that what if I am indicating it like this, it simply says that A and B are individual or independent keys for the given entity type. I should not do that. So what I can do now for the same thing, now let us assume that E is the entity type and then I have A as one attribute, B as one attribute, together they are going to form the key. Then I can conceive a complex or composite attribute, call them with some name, and then now I can do it like this. Now you can say that X is a key attribute for this entity type. This is how we can specify or represent composite attributes. Next, how to represent derived attributes. Derived attributes are those whose values are derived on the fly as and when required based on the values of some other attributes, stored attributes. Those attributes whose values are always stored in the database, they are called as stored attributes, and then we can always derive the values of these derived attributes as and when required. For example, if you take employee database or employee entity type, I have DOB, date of birth, which is a stored attribute, and then I have age, which I need to capture as a derived attribute. How can I indicate that? And then if the oval is with boundaries or with border is with a dashed line, it indicates that it is a derived attribute. Next, we need to talk about other notations like participation and cardinality and structural constraints like min-max constraints. Let us have a look at this. This is how we can represent participation. If it is a double line, these are the entity types and this is a relationship. And in this example, if you take the example 1, I have three examples here. And the first example, E1 and E2 are the entity types which are involved in some association or relationship with each other. For the relationships also I can give some title, like how I have named the entity types, I can also name the relationships. The name of the relationship here in this case is caps R. So that's why E1 and E2 are associated or they are involved in relationship. Now we join the diamond with the involving or associating entity type. If it is a single line, it indicates that it is the partial participation. If the line joining the entity type and the diamond is a double line, it indicates that it is a total participation. After a few minutes, in the next few slides, we will see what exactly is the meaning of this total and partial participation. And then we have cardinality. Cardinality means now we have E1 and then E2, which are entity types which are involved in relationship R. Now they are involved in association. Now how can I read this cardinality? I need to, now each entity of this type E1 is associated with one or more number of entities of type E2. That is the meaning. That is how we need to read or understand the cardinality. And I can read this cardinality either from this direction or I can do it from this direction. If I am doing it from here, I need to hide this and then read like one instance of E1 is associated with n number of instances of E2 or entities of E2 type. If I am reading it from this side, I need to hide this and then read it as one instance of type E2 is associated or has relationship with only one instance of type E1. That is called as cardinality. And then sometimes it could be 1:n and sometimes it could be 1:1 and sometimes m:n, something like that. And then we have another constraint that can be specified in ER modeling. These are all constraints that can be indicated or represented or captured in using ER modeling while doing conceptual database design. Then we have structural constraints, min-max participation. And suppose if I have a entity here E1 and then if it is E2, now what I can say is each instance of E2 type is involved in relationship with minimum of this and then maximum of this number of instances of other type E2. Similarly, here also I can specify minimum and then maximum, which reads like each instance of E1 type is involved in relationship with minimum this many number, maximum this many number of instances of this type. That is how we can read the cardinality, participation, and then min-max constraints in ER modeling. Let us, after some time, we will look at some solid concrete examples which will provide us more understanding about these concepts. Then coming to more details about the relationships in ER modeling, and this is how we represent relationships. Entity type, another entity type, the diamond indicates the relationship, and the line here, the lines are joining these entity types which are involved in the relationship with the diamond, which, and I can also include the name, I can give some name, attach some name to the relationship. And sometimes we can eliminate, we can do without specifying or indicating this diamond. This is also a valid representation of this relationships or associations. Then we have one more important notion called as degree of a relationship. What do we mean by degree of a relationship? If there are two entity types involved in a relationship, then it is called as a binary relationship. The degree is 2, it is called as a binary relationship. If you look at this example, the first one, it is a relationship where only 2 different types of entity types are involved. And the next one, if there are 3 different types of entity types involved, it is called as a ternary relationship. Sometimes it is possible that only single type of entity type is involved in the relationship, only one type of entities are involved in the relationship, they are called as unary relationship. Theoretically, any number of any different types of entities can be involved in relationship, and then that is why we can have n array relationship. If it is 4 array, what is the meaning? It says that n is 4, that is, it says that there are 4 different types of entities are involved in the relationship. This is about degree of the relationship, and we should be clear about the cardinality of a relationship and then degree of a relationship. Then coming into more details about the cardinality, let us have some examples about this. Relationships are really one-to-one, rarely one-to-one. Many times they are binary, or sometimes they are ternary. What do we mean by one-to-one relationship? Here, a cardinality and degree, they are many times they are one-to-one, sometimes it is one-to-many, and sometimes it could be many-to-many. And this is cardinality. Degree is something different, which indicates how many different types of entity types are involved in the association or relationship. That is degree. Now first let us discuss about the cardinality of a relationship. Relationships are rarely one-to-one, and sometimes it could be one-to-many, and sometimes it could be many-to-many. First, let us have a look at one-to-one relationship. This is man marries woman. Suppose the rule says that each man can marry only one woman, and then one woman can marry only one man. In such case, it is one instance of woman can marry only one man, that is one here, and then one instance of man entity type can marry only one woman, that is this is one-to-one relationship. Sometimes it could be 1 to m or 1 to, sometimes we also write it as 1 to n also, it is also correct. Now if we look at this cardinality here, we have department entity type and we have employee entity type. It is n to 1, or if I am reading it from this side, it is going to be, if I am reading it from this side, it is going to be 1 to n, and if I am reading it from this side, it is going to be n to 1. It clearly says that one department can have n number of employees, and if I am reading it from this side, one employee can work with only one department. That is why it is 1 to n relationship. And looking at the min-max condition here, what it says, one employee instance, it can work with, that is the name given to the relationship, one employee can work with only one department minimum, maximum one department. That means he must work, and then he must work with only one department. And if we look at the min-max constraint at the department entity type side, it says that every department must have minimum 5 employees and then maximum 10 employees. This is the min-max condition. And sometimes it could be 1:m also. For example, yeah, it is 1:n or 1:m. I can write it as m also, there is no problem. And sometimes it could be 1 to many. Suppose let us have an example of employee and project, then there is a relationship works on project, then it can say that one employee, the company rule says that one employee can work with any number of projects, and then one project can have any number of employees. Then it could be n is to m or m is to n. This is called as many to many relationship, one to one relationship, and then one to many relationship. This is called as the cardinality of the relationship. Now let us have a look at this participation constraint to have better understanding about the participation. If all the entities of an entity type are involved in the relationship, then that entity type's involvement is said to be total in that particular relationship. Otherwise, it is called as partial participation. If it is a total participation, the line joining this entity type which is totally involved in the relationship is indicated by double line. If it is a partial participation, the line is going to be single line. In this example, it indicates that each instance, if you take a specific instance of E1 type, that may be involved in the relationship or that may not be involved in the relationship. That is the meaning. That's why it is partial. If it is total, it indicates that, suppose if I have A, B, C as the instances of E2 or entities of type E2, then because the participation is total, it indicates that each and every entity of this type must have relationship with some entity of the other type. That is the meaning. This is called as total participation. For example, this is total participation. I have employee and then department entity types, and in this case works. Let us assume that the company rule says that each and every employee must work with some department and every department must have at least one employee. In that case, it is total participation on either side. So that's why these two lines have been, this line and this line are double lines, because if you have X, Y, Z as the employees and then if you have A and B or the departments, then the rule says that every employee must work with at least one department. It could be like this. So that's why it is double line on this side, and then at the same time the rule also says that every department must also have at least one employee working with that department. So that's why both the lines, both the entity types participation in this relationship is total. And sometimes in the previous example what we have seen, it is partial, that is employee. Suppose let us take the relationship managers between employee and then department entity type. The rule says that every department must have at least maximum one manager, and then some employees become managers. Suppose if I have X, Y, Z as the employees, if I have A, B as the departments, then since every department must have a manager, let us assume that employee Z manages B and then employee Y manages department A. And if you carefully observe, there are three entities available in employee type, but X and Y and Z are managers and X is not a manager. That means not all entities of this type are involved in the relationship. That's why it is partial participation indicated by a single line. And whereas in the other case, department entity type, if you look at A and B, according to the rule, each department has at least maximum one manager managing the department. So that's why its participation is total, which is a double line. Now, after having learnt all these constraints, and similarly we have binary, ternary and then unary, and then binary means you have, let us take the example, this is a binary relationship because you have only two entity types involved in this works for relationship. Sometimes it could be unary also, and if you take the person and marriage, a person can marry another person. A person can marry another person. That is, how many different, if a person is considered as a entity type, how many different entity types are involved in this relationship called marriage? There is only one type. So that's why it is called as a unary relationship. Unary relationship. This is degree. And whereas 1 to n, 1 to m, it is called as cardinality. And then how many different types of entity types are involved in the relationship is known as the degree of the relationship. And it is a binary relationship. And if you have three different entity types involved in the relationship, it is called as ternary. And similarly, you can have n-array relationship is also possible if more than any number of types, different types can be involved in the relationship. That is possible. But practically seeing, unary and then binary relationships are very, very common, whereas ternary relationships are rare, and 4 array, 5 array, n array relationships are really difficult to comprehend. So that's why we go maximum up to ternary relationship. If we increase that n, then it becomes more and more complex to understand and then design the database. Now let us have a look at some full-fledged example which captures or which represents a database, company database schema at logical level, and then at conceptual level, and which has all the concepts that we have learned so far. Company database, we have employees, we have departments, we have projects, and we have dependents. And employees work for department, that is one relationship between employee and then department. And one more relationship between employee and department entity type is managers, because employees manage departments. One important thing to be noted is, two entity types can be involved in any number of relationships between them depending on the requirement. In this specific example, the number of relationships available between employee and then department type are two. One is works for, second is manages. And departments control projects. So that's why there is a relationship called controls, which indicates what department controls which project. Then employees work on projects, so that's why there is a relationship called as works on, and which indicates which employee is working on which project, and at the same time how many number of hours he has worked on that particular project in a given month or week, whatever it is. And not only the entity types that can have attributes, we can also attach or associate attributes to relationships. If you carefully observe, the relationship called managers between employee and department entity type, they have a specific attribute, okay, which has come up because of this relationship and which is associated or attached to the relationship managers. Similarly, there is a specific attribute which can be attached to works on relationship between employee and then project type, which indicates what employee has worked for what number of hours on a particular project. Then we have dependent entity type and we have dependents of relationship. If you carefully observe, what is the representation or diagrammatic notation for strong entities? It is a single line bordered rectangle. So that's why it is a strong entity, this is a strong entity, this is a strong entity. All strong entities, they will have their unique identification and they will have keys. And weak entities are represented using double line borders and they don't have their unique keys. So that's why they are called as weak entities. Since the dependent entity type is having a double line bordered rectangle, we can see it as a weak entity. Now every weak entity should have some relationship with some strong entity or owner entity type. Here in this case, dependents belong to employees, that's why I have a identifying relationship between dependent weak entity type and then employee strong entity type, which is going to provide unique identification. The weak entities can get unique identification only in conjunction with or when they are associated with their owner entity types. Okay, so that's why now if you look at the attributes, the employee has SSN, and of course this is the key because it is underlined, there is no other key available. I have a strong complex attribute name which has subcomponents first name and then middle initial, and we have other attributes also, address, salary, and so on and so forth. I have one more relationship called as supervision. One employee supervises other employee, so that's why it is a unary relationship. It is a unary relationship, that is only one type of entity type is involved in the relationship and remaining all are binary relationships. Then if you look at the attributes of department, you have department number, name, and then location. Location attribute has a double line border. The double line border attribute indicates a multi-valued attributes. That indicates that a department, given department may be located at multiple locations like Chennai, Hyderabad, Mumbai, so on and so forth. So it is a multi-valued attribute. At the same time, number of, if you carefully observe this attribute, number of employees working with the department is a derived attribute. How can I derive the number of employees? It is, if you look at the association of this department entity type with the employees, then you can always compute how many number of employees are there at the given point of time working with that given department. So that's why it can be derived from some other stored attribute. So that's why it is called as a derived attribute. Number of employees is captured as a derived attribute. And now the project has project name, project number, and then location, and dependent has name, sex, birth date, and then relationship. And now, yeah, if you look at the cardinality, how can I give this cardinality to this 1:m or something like that? How can I do it? If you take this works for, the company rule says that every employee can work with only one department. So that's why each employee can work with only one department. One department, if I am reading it from this side, one department can have n number of employees. So this is 1:n relationship. Coming to the min-max conditions, the rule says that every employee can work with minimum one department, maximum one department. That is 1, 1, which is written on the line that is joining that corresponding entity type with the relationship. Similarly, if you look at this min-max condition which is attached, associated to the line, attached with the line, then what we understand, it indicates that each department can have minimum 4 number of employees, maximum any number of employees. Similarly, let us try to attach the cardinality for this relationship called as dependence of. The company rule says that a employee can have n number of dependents, and a dependent is always associated with only one employee. So it is a 1:n. Similarly, if you look at this employee and then project, one employee can work with any number of project, and then one project can have any number of employees. So it is a m:n, that is many to many relationship. And similarly, looking at this supervision, one employee who is a supervisor can supervise n number of employees, and then one employee is supervised by only one supervisor. It is 1:n. And coming to the min-max condition for this employee and then dependent, the rule says that if the company rule says that one employee can have any number of dependents, at the same time some employees may not have any dependent. In that case, maximum is 0, one employee can have no dependents, it is possible, and maximum any number. Similarly, the participation, if you look at the min-max constraint for the participation of dependent entity type in this relationship, every dependent must belong to one employee and maximum to only one employee. That is 1:1 relationship. And coming to this managers, if you look at the min-max condition, it indicates that one employee can manage 0 departments and then only one department, maximum only one department, because some employees may not be managers. And at the same time, if you look at this, a department will have maximum one manager, minimum one manager. Okay. And similarly, supervision, a supervisor can manage 0 employees and then maximum n number of employees, meaning that some supervisors are there who are not having any employees to manage, and one employee can have no supervisor, and then he can have and then he can be managed by at the most only one supervisor. And similarly, if you look at the min-max condition for this works on, we can say that one employee, if the company says that he must work with at least one project, that is minimum, maximum n number of projects, and it says that one project must have at least one employee, maximum n number of employees. This is the min-max condition. Now let us have a look at the participation constraints. What is the participation constraint between employee and then department? Of course, it is not properly indicated here. I have total participation, which is indicated by double line, and then I have partial participation, which is indicated by single line. Now if you look at the involvement of employee entity type in works for relationship, this relationship, what is the participation? The company rule says that every employee must work with at least one department, maximum one department. So that's why every employee instance has some association with at least one, maximum one instance of department type. So that's why this need to be a double line. This need to be a double line. So I can say that the participation of employee entity type in this relationship called worksphere is total. And if you look at this association of department in worksphere, it also says that every department must contain at least one employee working for the department. So it should be total, it should be a double line. And if you look at managers, this one, the company rule says that every department must have at least one employee managing the department, so it should be a double line, it is total participation. And on the other side, it need not be double line, because only suppose if you have 5 departments and then 1000 employees available in the company, only 5 employees can become managers, remaining 995 employees, they are not managers. So that's why it is partial participation. I have only a single line here. Then if you look at this participation constraint between this employee entity type and then dependent entity type, it indicates that dependent entity type, every dependent must have association with at least one employee, maximum one employee. That's why it is a double line, which says that it is total participation. And if you carefully observe this association, the company rule says that some employees may be there who are not having any dependent at all. That's why it is going to be a partial participation. It is partial. It is a single line joining the dependent of relationship with the employee type. What we call this relationship? A double-lined diamond, which indicates a identifying relationship between a weak entity and entity type and its owner entity type. That is min-max constraint. We have seen participation constraints, and then we have also seen the cardinality, and then degree. Coming to the degree of the relationship, it is a unary relationship, it is unary, and then remaining all are binary relationships. And then coming to the association between project and department, it says that one department can have association, one department can have n number of projects, one project is controlled by only one department. This is 1-to-n relationship. Actually, these constraints, the database designer cannot decide these constraints, and they should be defined or they should be given by those who clearly understand, who know the domain with clarity. That is, the domain experts only can give us information about the constraints. A database designer cannot decide these constraints. Okay. Now coming to the participation, it says that some departments can have 0 projects, maximum n number of projects. Every project must be controlled by one and only one department. In that case, its participation, some departments are not having any projects, so it is single line, and it should be a double line, because every project instance will definitely have some association with some department. So that's why it should be a double line. And then coming to the min-max condition, it is 1 1 and it is 0 and n. And this is and coming to this weak entity, now how we can bring unique identification to this dependent weak entity type? The instances can be identified with the name and the employee ID, which is the primary key, SSN in this case, which is the primary key of the strong or owner entity type. So that's why the name is also involved in identifying the weak entities in conjunction with the primary key of the owner entity type. So it can be underlined. When I underline this, suppose if it is a attribute and if I have name something like this, if it is underlined, it is called as a key, and then if it is underlined with a dotted dashed line, it indicates that it is a partial key. That means it is not a complete key, but it is going to participate, or it is going to get involved in becoming primary key for the weak entity type, and that works only in conjunction with the primary key of the owner entity type or strong entity with which it is getting associated. And this is how we can bring unique identification to the weak entities. Next, in this ER modeling, we can also capture superclassing and then subclassing concepts. We call them as class hierarchies. Sometimes it is natural to classify entities in a set into subclasses. Let us assume this employee entity type, which has employee ID, name and age as the attributes. Now if you carefully observe, based on some criteria, we can always classify the entities available in the employee set into 2 categories. and some may be in the, let us assume that there is a scenario where company has hourly employees and then contract employees, then we can classify, but both of them are employee type, they belong to employee type. So these hourly employee, and then which is a subclass of employee superclass, and then contract employee is also a subclass of this superclass employee. And hourly employee is a kind of employee, contract employee is a kind of employee. Okay, so this is called as superclass and these two are called as subclasses. In this example, what we have is, first I have superclass, and based on some criteria I could classify the instances in superclass into two categories. It is called as specialization. In specialization, the employee entity type or entity set is specialized into hourly employee and then contract employee. This is in this direction. That means first I have a superclass, then I could derive subclasses. And in some cases what happens is, first we have subclasses and then based on the commonality then we can derive superclasses. For example, if I have a car and then if I have a bus and both have some capacity, both have some vehicle number and then both have some cost. Okay, so in that case, yeah, so now what I can do, both are the common attributes can be taken into the superclass and I can come up with a superclass, and then I can associate the common attributes which were commonly available in these subclasses as attributes of the superclass. The specific attributes which are very, very specific to the subclasses will remain with the subclasses themselves. In this particular example, if you carefully observe, the number of hours, which is a specific attribute which is always associated with hourly employee, and it can be it has some meaning always with hourly employee entity type. And then contract employee also has a specific attribute called as contract ID. Okay, now if you look at this class hierarchies, and when you have subclasses first and then derive a superclass, it is called as generalization. We say that hourly employee and then contract employee are generalized by employee entity type or superclass, and then if we have superclass first and then derive subclasses, it is called as specialization. Okay, both specialization and generalization concepts or mechanisms, they lead to class hierarchies. Now let us have a look at one more example for class hierarchies. Here I have employee entity type which has age, employee ID and name. Of course, employee EID should be underlined because it is the key. Then I have subclasses, technical employees, non-technical employees. And for technical employees, the specific attribute is branch with which they are associated, like mechanical, civil, electrical, so on and so forth. And for non-technical employees, there will be skill, managerial skills, typing skills, shorthand, so on and so forth. So these are specific attributes which are associated to subclasses. This is called as a superclass, this is subclass. And first I have subclasses and then derive superclass, it is called as generalization. First I have superclass and then derive subclasses, it is called as specialization. And here, if you carefully observe, in this I can have any number of classifications. For example, if you take vehicle, one kind of classification is I can classify them into light vehicles and then heavy vehicles. This is one classification, and depending upon some other criteria whether they carry passengers or goods, I can classify them into passenger vehicle and then goods vehicle. Like that, there can be, for a given entity type, depending on the requirement, depending on the situation, there can be any number of classifications. And further, if you carefully observe, we can associate some constraints with that. Overlapping constraint, covering constraint. And if you look at this, it says that employee can be a technical employee and then non-teaching employee. In this circle which is on the line which is joining these to the superclass, I have written the letter D, indicates that disjoint, they are disjoint, meaning that an employee can be either technical employee or a non-technical employee, not both. This is the set, these two sets are disjoint. And sometimes what happens is, it can be overlapping. Suppose if you look at this classification, a vehicle classified into passenger vehicle and then goods vehicle, sometimes a passenger vehicle can also carry goods. In that case, it is called as, written as O in this circle, which indicates overlapping participation or overlapping subclassing or specialization. If it is D, it is disjoint. If it is O, it is overlapping. That means some vehicles are there which are passenger, which are goods, and some vehicles are there which belong to both the categories. And here, whereas in this case it is going to be disjoint, meaning that a vehicle can be a light vehicle or heavy vehicle, it cannot be both. and at the same time there is one more constraint called covering constraint or participation constraint, which indicates that whether each and every instance of superclass is participating in that classification or not. And if you consider this, let us assume that every vehicle must be a light vehicle or a heavy vehicle. In that case, its participation of superclass in subclassing is total. It is called as covering constraint, total participation. And whereas in this case it is a double line, in this case it is a single line, indicating that if at all there is a vehicle, it may be a passenger vehicle or goods vehicle, sometimes it could be both, or sometimes there may be some vehicles which are not participating in any of these categories. For example, an ambulance, it is a vehicle, it is neither a passenger vehicle nor goods vehicle. So that's why some of the instances of the superclass are not participating any of the subclasses. So that is called as partial participation of the superclass entity in the subclassing. It is partial, so it is a single line representation indicating partial participation. Finally, let us have some introduction to how UML can be used. Unified Modeling Language can be used for conceptual data modeling. Like at designing conceptual database schema, we can have, as we have used ER modeling, similarly we can also use UML modeling technique. Unified Modeling Language, and which is a popular modeling language for defining, designing, implementing, documenting object oriented software. We can model a database at conceptual level using UML also. UML constructs can be drawn as diagrams, like what we have seen with the ER modeling, which is completely diagrammatic. Similarly, UML is also graphical representation. Okay, you have notations and then notions. For every concept which we call it as a notion, you have notation, that is some symbol or diagram indicating or representing that notion, concept. What we can do with UML? You can do business modeling, that is you can describe the business process involved in the software. You can do system modeling, specify the requirements using use cases. You can do conceptual database design like what we have done with the ER modeling, and to do this conceptual database modeling we use class diagrams. Instead of writing rectangles for indicating entity types, we use class diagrams or the notations for classes, indicating classes. We can also do physical data modeling for modeling indexes and then table spaces. Hardware system modeling can also be done, which describe the hardware system configuration for the software system. And class diagrams can be used to describe the database at conceptual level like ER diagrams. Please note that we are not going to have full length details or discussion about how UML can be used for conceptual data modeling. Any standard book, you please refer to standard book to get the details about this. And in this class we have seen what is conceptual database design, what are the various steps involved in database design process, what is entity relationship modeling, concepts and notations that are used in ER modeling, and class hierarchies, how we can capture the subclassing and then superclassing specialization generalization in ER modeling. And we have also seen some brief introduction to how we can use UML for conceptual database design. Thank you very much.